Welcome to Unit 7, Intro to Trig, Trigonometry, one of my favorite units. So just before we start, I just want to make sure that I go over a couple points that we went over in class. Make sure you don't have distractions, meaning that your phone is not out or you're listening to music in the background while the lesson is going on. Make sure you're writing down the notes. All right, you're writing down the notes. You're using your notes packet to go along and highlight and write down the notes that I'm writing down. Make sure that you pause and rewind if you need to. All right, I think that's important. That's a very good part. So you're picking up all the pieces of the lesson. Make sure that you do the problems to check your understanding. All right, so you're applying what you've learned in the lesson. I think it's also important that you write down the key ideas, all right, in your own words. So we'll go over those key ideas when we get into class the next day. So make sure those are written down. And then most important, make sure you're writing down questions that you might have. Any questions you might have during the lesson so that we can bring it to the class the next day. Your question is important and it might be a question that someone else might have. So don't trust your memory and make sure you write them down. All right, intro to trig, basic trig ratios. So in the first paragraph there, you can read, that's just a definition of trigonometry, but the trig ratios. And then we know that ratios can be written as a fraction because that's a relationship between two numbers, or we're going to see two sides. So those ratios, trig ratios, are built off right triangles. So let's go through and talk about the different pieces of a right triangle, which we've done in the past. Okay, so I have my right angle. I have my side opposite the right angle, which is my hypotenuse. I also have the sides that make up my right angle. All right, they're called legs. Now, it says there are three basic trig ratios, sine, cosine, and tangent. Given a right triangle, you can find the sine or cosine or tangent of either of the non-90 degree angles. And that's important because the angles that we're going to look at in terms of that relationship, it's going to be those acute angles, okay, not the 90 degree angle. The first one is sine theta. Now, theta is just a Greek letter that we use in trigonometry quite a bit to represent the angle. It says sine, I'll write the word out, sine theta equals the leg opposite the angle over the length of the hypotenuse. So that is sine equals the opposite, okay, the leg opposite over the hypotenuse. And then cosine of theta, it equals the length of the leg adjacent to the angle, adjacent, which means next to, very important, over the length of the hypotenuse. Okay, so another way of representing that is C equals the adjacent A over the hypotenuse H. And then the last one is our tangent. Our tangent of theta equals the length of the leg opposite the angle over the length of the leg adjacent to the angle. All right, so opposite the angle over adjacent to the angle, those legs. So we have T, or tan, equals the opposite over the adjacent. Now, these three basic trig ratios have to be memorized. Now, one way that I learned to memorize it was sine opposite over hypotenuse, cosine adjacent over hypotenuse, and then tangent opposite over adjacent. So katoa. All right, that was big back in my day. SOHCAHTOA. I've heard some other ones since, but we are going to stick with SOHCAHTOA. All right, now something important. It says the length of the leg opposite angle. Now, I just want to stress this, angle A. All right, so that's capital A. For the angle is A, and that would be our side. All right, so our side is in small a. And then the length of the leg opposite of angle, notice again, large B or capital B, angle B is small b. And the length of the hypotenuse opposite angle C, again capital, is small c. All right, so those sides are in small letters and the angles are in the big letters. Okay, let's take a look at example 1. It says, write expressions for the sine, cosine, and tangent of angle A. Then write expressions for the sine, cosine, and tangent of angle B. Now, some strategies here. My first strategy for this is that I am going to write down sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. I really suggest you do this on your paper until you get these trig ratios memorized. Very important. Next strategy, we're looking for angle A, the relationship of angle A for sine, cosine, and tangent. So what I do is I go over and I highlight angle A because that's the angle that we are looking at in terms of its relationship. Now what I do also after that, after I highlight the angle, is I go ahead and I identify the side opposite A, straight across. That's the way I like to think about opposite. All right, so that's small a. Now, C is going to be my hypotenuse. That's never going to change. All right, so the side opposite the right angle is always my hypotenuse. And then the other side, the side left over, is going to be my adjacent. So now I can start writing down my ratios. So I have sine of angle A. You always have to write some angle. That's important. All right, that relationship's of an angle equals, well, my opposite is small a, and that's going to be over my hypotenuse. My hypotenuse is C. And then the next is my cosine. The cosine of A is going to equal my adjacent, which is B. That's going to be over my hypotenuse, which again is C. The last one is my tangent. My tangent of A is going to equal my opposite, which is A, over my adjacent, which is B. Now, the next thing we have to do is the same thing for angle B. So what I'm going to do is I'm going to erase, except I'm going to leave my H because my H stays the same. I'm going to highlight angle B. All right, I'm going to identify my opposite straight across, which is side B or small b, my hypotenuse, which is C, and the adjacent is going to be next to it. Give that ADJ. All right, now, so I can start writing my ratios. So my sine of angle B, it's going to be my opposite, which is small b, over the hypotenuse C. Okay, my cosine of B, cosine of angle B, is going to equal my adjacent, which is A, over my hypotenuse, which is C. And then the last one, tangent of angle B is going to equal my opposite, which is small b, over the adjacent, which is A. All right, now, example 2. In the triangle below, find the 3 trig ratios of theta. There we go again. All right, express your answer in simplest radical form. All right, now, again, my strategy. So I'm going to highlight theta. I'm going to highlight that angle. I'm going to look for my opposite straight across. Okay, and I can put an O there. All right, my opposite is 5. Okay, I'm going to look for my hypotenuse. All right, that's H, always opposite the right angle. And then the last one is my adjacent, the side next to my angle. Now, I have a problem here because I don't have the hypotenuse, but I do have a right triangle, and I'm missing one side. So what am I going to use to find the missing side? That's right, Pythagorean theorem. So that's going to be a squared plus b squared equals c squared, where c is the hypotenuse. So I'm going to set it up. So I'm going to have 5 squared plus 2 radical 3 squared equals c squared. All right, so I know 5 squared is 25. That's going to be plus, if I can use my calculator, 2 radical 3 squared is 12. And that's going to equal c squared. I'm going to have 37 equals c squared. I don't want c squared, I want c. So in order to do that, I have to do the opposite. I have to square root both sides. So I'm going to get c equals the square root of 37. And I can leave that, that's fine. So my hypotenuse is the square root of 37. All right, so now I can start identifying my sine of theta, my cosine of theta, and my tangent of theta. So let's write that down. So the sine of theta, what did I forget? All right, very important. Let's put over here, sine equals opposite over hypotenuse. So ka toa. All right, now, so sine of theta, opposite over hypotenuse. So my opposite is 5. My hypotenuse is square root of 37. My cosine of theta is my adjacent, which is 2 square root of 3 over my hypotenuse, which is square root of 37. And then my last one is my tangent of theta. That's going to equal my opposite, which is 5, over my adjacent, which is 2 square root of 3. All right, good. All right, so that's our introduction to our trig ratios. What I want you to do right now is I want you to write down key ideas, which we will go over tomorrow, and I want you to use your notes to do the problems 1 and 2. Check your understanding. Thank you, and go Cats, go Knights.